Good morning, it's Mr. Smith again. Here we're doing some more graphing. This time we have a linear and an exponential all being graphed on one plane. This is what the majority of your test graphing question will look like. You'll have a coordinate plane, you'll have some functions, you have to identify the function and tell us the parts and graph it as well. So I'm going to go through it and we'll go from there. So anyway, we can see we have two functions. We have this one and we have this one. So we have y equals negative 2x plus 1. And hopefully most of you can realize that this is in y equals mx plus b form. So therefore it has to be linear. Hopefully from foundations you remember the domain is always negative infinity less than x less than infinity. And the range for a linear is always negative infinity less than y less than infinity. Hopefully you remember from 6th grade that the b term, so this is our b term, is our y-intercept. So we know the b is our y-intercept. So I'm going to put y-intercept. So we know it's going to be 0, 1. And just for extra information, I know they don't ask for it, but remember our m is our slope. Very good. So the very last thing that we have to fill in this table for this function is our horizontal asymptote. And does a linear function have a horizontal asymptote? No, it does not. So you have to write none because it does not have one. So the very last thing we have to do is graph the function y equals negative 2x plus 1. So in order to graph it, we're going to start off at our y-intercept, which is 1. So I'm going to go to 1 on the y. So remember, this is our y here, and this is our x. So I went to 1 on the y, our y-intercept. And our slope is negative 2. So I'm going to write m is equal to negative 2. And you can write that in rise over run form, which is negative 2 over 1, which means we need to go down 2 and over 1. Down 2 and over 1, down 2 and over 1. And then all you do, you take a straight edge. I don't have a ruler on me, so I'm just going to use this right here. And then we're just going to draw a line. And then we'll put some arrows at the end. And we're done with that one. If you wanted to, instead of using rise over run form, just like with exponential, you know we make an x, y table. You can do the same thing for a linear. So I can plug in 0, and negative 2 times 0 is what? It is 0, and 0 plus 1 is 1. And then you can do the same thing with 1. So when x equals 1, you plug in 1 for x, and you get negative 2 plus 1, and negative 2 plus 1 is negative 1. And you can do the same thing for 2. So instead of having a 1 here, we're going to put a 2. So negative 2 times 2 will give us negative 4, and negative 4 plus 1 will give us negative 3. And you plot those 3 points, 0, 1, 1, negative 1, and then you go over to 2 and down to negative 3. And you'll get the same point. So whatever method you prefer, use the method you prefer. Sometimes it'll be easier to use rise over run, sometimes it's easier to just to plot points. But for exponential, this is the most recent thing that you have learned. We always want to create our table. Please remember, if you have Mr. Behringer, to always start with negative 1. So let's go ahead and start with 0. So we have y is equal to 2 to the 0 minus 3. 2 to the 0 is 1, and 1 minus 3 is negative 2. I'm going through this kind of fast because in the previous 2 videos we really kind of broke it down. So if this is too fast for you, definitely go back to video 1 or video 2. This is 2 to the first minus 3. So we get 2 minus 3, and 2 minus 3 is negative 1. And then we have our last one where we have x is equal to 2. So we have y is equal to 2 squared minus 3, and that's going to be 4 minus 3, which is just 1. And so let's go and fill out this part, and then we'll go back and plot our points. So again, I didn't really talk about it, but hopefully we all realize this is AB to the x, because we have x as an exponent, so therefore it's exponential. I just assume that we realize that, because anytime we have x as an exponent, so anytime x is an exponent, it's exponential. We know our domain is always negative infinity, less than x, less than infinity. We're going to come back to the range. Our y-intercept is in our table. So we have 0, negative 2. And our horizontal asymptote is always the number after x. So we have y is equal to negative 3. And remember, our horizontal asymptote is the low point. So the low point is negative 3 for our range. We know the middle part is less than y less than. Remember, our graph exponential growth is going to shoot up, so it's going to be positive infinity. So pretty much, if you remember horizontal asymptote is the low point, you'll be pretty good with the range. So I'm going to go and graph the low point, which is negative 3. So 1, 2, 3. So this is negative 3. So dot it, dot it, dot it. And then we'll plot the points. So we have 0, negative 2, 0, go down to negative 2. We have 1, negative 1, so we go to 1, we go down to negative 1. We have 2, 1, so we go over to 2, and we go up to 1. And so it's probably going to shoot up something like this. And now we have both graphs. The thing we have to be careful of, I know it's right here at the bottom, you can barely see it. It says, where do the two functions intersect at? So intersect is just another word for where do they cross. And hopefully you can see that they cross right here where we have blue and red. And this point would be 1, comma, negative 1. So I'm going to write 1, comma, negative 1. And we're done. Again, if you have any questions, please feel free to go back to video 1 or video 2, or you can rewatch this one. I hope this helped.